We will discuss about the concept of structural design code and standards. Dr. Muhammad Abdullah Ridi. We can contact us at any time at www.readyman.com. We will discuss now about the concept of the structure. What about the codes and the standards? What is the difference between the American code and the British standard? What about the ACI, American Computer Institute, AISC, American Institute of Steel Constructions, the code of the American standards, British standard for steel concrete, EC2 and EC3 for the European standard, IS India, ECB, which Egyptian code, and whatever any country code, we need to make a difference between them. What about the concept? Many paper and articles engineering worldwide about the difference between these codes, the conservative, non-conservative, and so on. Really, it is important to discuss this issue for many reasons. The first one, when you make the design itself, a lot of questions and a lot of discussion when you deal about some conflict between the consultant, the owner, who is reviewing. I think they are the conflict because the concept is not in their mind. This is the main problem that I need to highlight it here. When you make the design, because in the college, university, civil engineering university, and so on, civil engineering faculty for any university worldwide, it just give you the code, the standard. This is the factors that you are working with, and so on. Let us go to the design, do the design, drawing, and so on. What is the concept behind? That's we need to discuss here. Because when you are working as a professional engineer, you need to know exactly what is the concept behind. Then we go through about load resistant factor design, ultimate state, limit state design in case of the concrete itself, and WSD, working stress design, allowable stress design, and the concept of structural reliability. Or by another mean, we called it the structure probability of failures that we need to be discussed now. What about the history itself? The history on the past for 1970, before many research and development 1960, in the last 1960 and first 1970 about the load resistant, all the ultimate stress design for concrete and load resistant factor design. But until 1970, 1980, start working with working stress design. For the steel, until now, we still working with allowable stress design, and there are ISC, ASCD, it's available in the market. What is the change, what happened, and so on. On the past, what about the engineering design that we do in the past? Here is, for example, here is the stress strain curve. This strain curve, stresses. Let's start our course about the fatigue and the thermal stresses. This is a very important subject that all the structures, system in industrial in general, oil and gas, power generation project, general industry, should be directly affected by fatigue and thermal stresses. In most cases, it is have some special features for this type of the stresses itself. So we need to be understand very well to be account or consider during the design itself. Let's start by fatigue stresses. Fatigue property, fatigue. About another topics that we need to discuss here about the thermal stresses. Thermal stresses temperature effect on the building or structure itself. The structural analysis of the building should include a determination of the need of thermal expansion joint in the view of potential impact of temperature produce dimensional change on structural integrity and the building serviceability, as maybe have some deformation can be happen or cracks due to thermal effect or temperature effect. In general, delta T equal alpha. This is the L. here according delta T change in temperature L the alpha which is a coefficient of thermal expansion. So what about the extensions of increasing the length itself? Alpha, every material has the alpha. For example, steel beam, it will be 12 multiplied 10 minus 6 degrees centigrade